Question 1. 5p take away 3p is 2p, and 2p plus p is 3p. Now m cubed plus m cubed is just 2 lots of m cubed, so 2m cubed. Part C. Question 2. Now one significant figure means you're only allowed one non-zero digit in your answer. So 56.78, we're either going to have to go for 50 or 60, and this is nearer. Question 3. What is the most popular type of transport used by the boys? Well, the boys are the grey colour, so the highest column for the boys is this column here, which is 9, so the boys are walking. Part B. 7 girls walk to school. Show the information on the dual bar chart. So here's where we're going walking. So for the girls, we're using this striped format. We need to go up to the number 7. Question 4. Write these fractions in order of size. So it is a calculator paper, so of course you could just choose to change them all to decimals and compare these. That's absolutely fine. Or alternatively, you can just look to have them all with a common denominator. Now all of these numbers are factors of 30, so 30 can be a common denominator. So with this first fraction we times top and bottom by 6, so that's 12 over 30. The second fraction is obviously already over 30. With the half we multiply top and bottom by 15, 15 over 30, and with 7 over 15 we double top and bottom, giving us 14 over 30. Now these are all easily comparable now they're both over the common, they're all over the common denominator of 30. So 11 over 30 is the smallest, then 2 over 5, then 7 over 15, and finally a half. So part A, write down one thing that is wrong with the tally charts. Well, we can see that Monday's tally has been added up incorrectly. This should be 5 plus 5 plus 3, which is 13, not 12. Part B, write down one thing that is wrong with this pictogram. Well, we can either go and say that we got an extra one of these for Tuesday needed, because Tuesday we need to have 18. Each of these circles with a line through it counts for 3. So we've got 3, 6, 9, 12, 15. So we're missing an extra circle here for Tuesday. Or secondly, we can see that we've got the Wednesday one wrong because we need to have 8. Now half of one of these, half of 3 is 1.5. So for Wednesday, as things stand, we've got a 3, a 3 and a half, which is going to be a 1.5. So these only add up to 7.5 and not 8. So either of those two things could be written down, because the question only requires you to write down one thing that is wrong. Question 6. So to start with, we need to work out how many of each type of coin we've got. Now we're told we've got a third of the coins are £1 coins. So 495 divided by 3 means we've got 165 £1 coins. Now we're told we've got 124 50p's, and the rest of the coins are 20p coins. So how many 20p coins have we got? Well, it's the total of 495, take away the 165 £1 coins, and take away the 124 50p coins, means we've got 206 20p's. So 165 £1 coins, 124 50p's, and 206 20p's. So multiply. Question 7. Well, the probability of a fault added together to the probability of not a fault has to be a whole. So to work out this, we just do 1 and take away 0.015, giving us a probability of 0.985. Question 9. Well, the only square number there is 25, because 5 times 5 is 25. From the numbers in the list, write down a number that is a multiple of both 4 and 6. Well, 24 is a multiple of both 4 and 6. 4 sixes are 24. Now, part C, write down all the prime numbers in the list. So working our way across them, 21 is not prime because we could have 7 threes. 22 is even, so that can't be prime. 23 is prime. Question 9. Well, the angles about a point, the angles all the way around in a circle add up to 360 degrees. Now we've got 90 degrees here, so 360 take away 90 degrees is 270. So this 2x and the 3x combined have to equal 270 degrees. So that's 5x equaling 270 degrees. So we've constructed an equation. So it's quite a simple one to solve. We just have to divide by 5. X equals 270 divided by 5, which is 54 degrees. So we need to buy 150 envelopes. So let's look at each offer in turn. So letters to send. A pack of 25 costs £3.49. Well, we need 125 envelopes, 25 in each pack. 155 divided by 25 means we need 6 packs. Each pack costs £3.49, so that's going to be 6 times £3.49, which is £20.94. Now for Stationery World, a pack of 10 envelopes is for £2.10. You buy one, you get one free. So we 30 envelopes. Think about what 30 envelopes is going to cost us. 30 envelopes is going to be 3 packs, isn't it? Because we 10 envelopes in a pack. So if we consider question 11. So part A, change 74 centimetres to inches. So centimetres are on the y-axis. Find 74. Just be careful to with the scale. Every baby square is 2, so 74 is here. Go along, hit the conversion graph, go down and take a reading, and down here every baby square is 1, so that's 29. Now for part B, what is Daniel's height in centimetres? Well, 6 feet and 3 inches is 6 12s are 72, plus the 3, that's 75 inches. Now just take a reading that you can use to then convert. So I've taken 25 inches being 63 centimetres. So if I then go and multiply by 3, 75 inches is 3 lots of 25 inches, so it's going to be 3 lots of 63 centimetres, which is 189 centimetres. So you just need to take a reading and then using proportion convert that into 75 inches worth. Now the mark scheme allows a bit of flexibility because it's quite hard to read. The question 12. Now with these, I think it's really helpful to use that fractions button on your calculator, which is like the white rectangle over the black rectangle. There's normally about 3 buttons down on the left on your calculator. Then using the arrow key, put this in the numerator, arrow key to move down into the denominator, and just enter this into the denominator and you should be fine. Answer is this. Question 13. So to rotate a shape, make sure you use the tracing paper provided. So pop the tracing paper over shape A and make sure it's going over the centre of rotation, which is 0. Trace round shape A. Now a little tip, do an arrow pointing upwards on your tracing paper. Now we need to do a rotation by 90 degrees. So popping the pencil on 0 as a pivot, move the tracing paper around until the tracing paper has turned 90 degrees clockwise, so the arrow will now be pointing to the right and the shape will have moved over here. So draw through the draw on the tracing paper again, pressing quite hard to get an indentation on the paper below, and then obviously remove your tracing paper and just draw the shape in. Now for part B, we can see that we've reflected question 14. Now factorise means to put the brackets in. So what's the highest common factor in 5 and 10m? Well, it's the 5. So the 5 comes outside the bracket. Open up a bracket. 5 times what gives us 5? Well, that's 1. Get the sign right, it's a minus. And 5 times what gives us 10m? Well, it's 2m. Now these are easy to check, just expand and check you get back to where you started. So do the 2 claws and make sure when you multiply out the bracket you get back to where you started. Now part B, we've got to put the brackets in again, but be careful, follow the word fully. Fully is telling you that there's going to be more than one item coming outside the bracket. So with part A it was just the 5, but here we're going to be having at least more than one coming out. So we work our way along. So what's the highest common factor of 2 and 6? It's 2. What's the highest common factor of a squared and a? It's a. Question 15. So part A, write this as an ordinary number. So it's got a minus power, so it's going to become smaller. So we just need to move the decimal point 1 to the left, giving us 0.47. You could just put this into the calculator and it will give you the answer. Now for part B, again, I would suggest you start with the calculator using the times 10 to the power of x button, which is normally right down at the bottom in the middle on your calculator. Just write that literally into your calculator and press equals, and it will give you the answer in normal format, in normal numbers. So 228 and all those zeros. Now we've got to give our answer in standard form. So remember what the process is here. The first number's got to be between 1 and 10. So where do we put the decimal point to get a number between 1 and 10? Well, it comes between the 2 2's. So we've got a 2.28 as a starting point, and then times 10 to the unknown power at the moment. Now we know the power is going to be positive, because this is a big number, and then the power is just how many hops does the decimal point go to go from where it's really starting, which is right at the end, to being between the 2 2's. So how many hops is that? 1, 2, 3, 4, 5, 6, 7, 8, 9 hops. So it's 2.28 times 10 to the 9, and again you can check that answer on your calculator by popping that in and pressing equals. Question 16. So on the map show one of the possible positions for T, and T is equidistant from the point P, B and C. T is also 250 meters from point A. So let's take this first statement first. T is 250 meters from point A. Now 250 meters is going to be 2.5 centimeters on our scale drawing, because 1 centimeter represents 100 meters. So we know T is somewhere 2.5 centimeters from A. So getting out our compass, measure the distance between the pin and the pencil point to being 2.5 centimeters using a ruler, and just do a big arc around there, so we know T sits somewhere on that purple line. Now the second fact we know about T is that it is equidistant from the points B and C. That means wherever it is, B and C are the same distance apart. So we need to draw in what's called a perpendicular bisector. Question 17. So first things first, let's work out the probability that we land on a 1. So the probabilities have to add up to a whole. So if we add up the 0.17 and all the other numbers, that comes to 0.69. So the probability of landing on a 1 must be 1 take away 0.69, which is 0.31. So the probability that you will land on a 1 or a 3 is the probability you land on a 1 added together with the probability you would land on a 3. So 0.31 add 0.18, which is 0.49. So if you throw the bias dice one time, the chances of landing on a 1 or a 3 is 0.49. But you're throwing the dice 200 times, so how many 1s or 3s would you expect to get? Well, it's 200 lots of 0.49. 200 times 0.49 is Question 18. So with one like this, you've just got to take your time and work your way through the information. So I've just done a little table to help me gather my thoughts. So 117 children had seats in the circle. So circle, children, 117. Right, now I'm told that 3/4 of the children had seats in the stalls. Well, 117 children are in the circle, so that must be 1/4 of the children. So the numbers in the stalls, which is 3/4, has to be 3 times the same amount. So that's going to be 3 lots of 117, so which is 351. So how many children have we got in total? 117 add 351, which is 468. So we know we've got 468 children. Now back up to the fact near the beginning, the ratio of adults to children is 5 to 2. So there are 5 adults for every 2 children. So 468 represents 2 shares, represents the 2 children. So if I divide that by 2, that gives me 1 share. Multiply that by 5, that tells me that there are 1,170 adults present. So 1170 adults, 468 children, so that's 1638 people in total. So the cinema, question 19. On the centimetre grid below, draw the front elevation and the side elevation of the prism using the scale 2 centimetres to 1 metre. So front elevation, imagine you're looking from here, so the shape is going to be this shape here, and then 2 metres represents 4 centimetres, and so on. So basically all of these metre lengths we're going to have to double to get the number of centimetres we want. So we need to have a base of 4, a height of 4, a height over here of 1, and then we pop in the diagonal. Now secondly, we then got to draw the side elevation, which is looking from here. Now this bit will be in the foreground, this little rectangle here would be in the foreground, being 2 meters by 2 centimeters by 1 centimeter on our diagram. But of course, if you're standing here and looking at the building, this sort of slanted roof, if you like, you're going to see that, and it goes all the way back to a height of 2. Question 20. So draw a little diagram to help you gather your thoughts. Liverpool to Manchester to Sheffield, 56 kilometres, 61 kilometres. Now the first thing we're told is that Ollie's average speed from Liverpool to Manchester was 70 kilometres per hour. That means he goes 70 kilometres in an hour or 70 kilometres in 60 minutes. But going from Liverpool to Manchester, he doesn't have to go 70 kilometres, he needs to go 56 kilometres. So I need to apportion this for it to be just 56 kilometres. So I take my 60, I divide by 70, multiply by 56. So this part of the journey takes me 48 minutes. So speed is distance over time. So the average speed for the whole journey from Liverpool to Sheffield will be the whole distance divided by the whole time. Now the whole distance, of course, was 56 kilometres at 60. Question 21. Well, we've got 2 similar triangles here because of these parallel lines. So this the big triangle from A to E to C is just a bigger version of the smaller triangle from B to D to C. So if you just isolate these 2 triangles and fill in what you know, this allows us to really sort of gather our thoughts. So we can see we've got the base in common. So how do I go from 8.1 to 5.4? What do I multiply it by? Well, on my calculator I've done 5.4 divided by 8.1, and I can see that I get 2/3. So the smaller triangle is 2/3 the size of the bigger triangle. So work out the length of AE. So AE is this length here. So I've got to take my 2.6 and I'm going to divide that by 2/3, or multiply it by 1.5 if you prefer, same thing, multiplying it by 3/2, and that. Question 22. So let's look at personal bank first of all. So we're investing 25,000. Because the interest rate is 2%, our multiplier is going to be 1.02. And we're investing at this rate for 3 years, so the power is going to be 3. Pop that into a calculator, we get 26530.2 being the amount of money at the end of, in total at the end of the 3 years. Now with Secure Bank, in the first year the interest rate is 4.3. So that gives us a multiplier of 1.043, and that's only for 1 year, so that power is 1. Now for the other 2 years, our interest rate is 0.9%, so that gives us a multiplier of 1.009. That's for the other 2 years, so that's squared. And multiplying that, we get 26546.46. So we can see that the money we end up with after the 3 years is greater from the Secure Bank. Secure Bank gives the most interest. So rounded to 2 decimal places, we get 4.76. So our upper bound is going to be 4.765. And our lower bound is going to be 4.755. Now we do round up when it's 4.755. That's why we've got n being greater than or equal on the left. But actually at 4.765 we would round up, we would not round down. So with that one we must have the inequality sign being less than, not less than or equal. Question 24. So to solve this, we're going to have to start by factorising the left-hand side. And when we factorise a quadratic equation, and a quadratic equation where we've got some x squared, some x's and some normal numbers, we know when we factorise we're going to get a pair of brackets, and the first term in each is going to be x, because our x times our x will give us our x squared. So we need to work out what these two numbers are here. Now these two numbers, when multiplied together, give us minus 24, the term on the end. But when you add them together, they give you plus 5, the coefficient of x, the number in front of the x. So which two numbers satisfy this? Well, this is minus 3 and 8, because minus 3 times 8 is minus 24, but minus 3 add 8 is plus 5. So our magic numbers when we factorised are x minus 3 and x plus 8 equaling 0. So that's just having factorised. Now having done this, it's very easy to solve. What value of x would make this first bracket 0? Because 0 times whatever is 0. Well, to make this first bracket 0, we need x to be 3. And then secondly, alternatively, how can we make the second bracket 0? Because 0 times whatever's in the first bracket would also be 0. Well, to make the second bracket 0, we need x to be minus 8. So our solutions are 3 and minus 8. So note how your solutions have the opposite sign to the two numbers when you factorised. Question 25. So we need to find an expression for the nth term. So this is really just a process you need to learn. So first of all, what are we going up in? We're going up in fives. So our first term is going to be 5n, and had we been going up in sixes it would be 6n and so on. And then we have to do a little adjustment, and this adjustment is what we call the 0th term. What number would come at the front of the queue if it pushed in? Well, we can see that as we go from right to left we're going down by 5s, and 3 take away 5 is minus 2. So our adjustment, our 0th term, is minus 2. Now for part B, is Nathan right? So Nathan says the 4th term of this sequence would be 144. Now when it's the 4th term, that is when n equals 4. So we just substitute 4 into this nth term expression and see if we get 144. So substituting 4 in, we get 4 4s are 16. We do the following BIDMAS, we do the power first, so that's 16. 16 times 3 is 48. So Nathan is not right. The 4th term, and why is he not right? It's because you need to square before you do the multiplication by 3. What Nathan's done, he's done 3 4s are 12 and then squared it, rather than squaring it and then timesing it by 3. So, so Nathan appreciated we had to substitute 4 in. He's just done it incorrectly because he hasn't done it in the right order.